Everyone, in the last session you have seen about security testing, which is a part of non-functional testing. Today we will see some more type of non-functional testing like compatibility testing, upgrade and installation testing, and recovery testing. So what exactly is compatibility testing? As the name suggests, compatibility. What do you mean by compatibility? So compatibility testing is a type of a testing that ensures that an application or software performs as expected across different environments, platforms, and configurations. We have to check that our application is compatible with different environment, platforms, and configurations. This type of testing verifies that the software can run on various browsers, operating systems, hardware, mobile devices, network environments, and alongside other applications as well. Primary goal of compatibility testing is to identify the compatibility related issues that could affect the user experience or the functionality of the software. So it is mainly related to compatibility with different type of environments, software systems, hardware, mobile devices, network condition, etc. So there can be a different type of compatibility testing. So we will see one by one. For example, operating system compatibility. So whenever we develop any software application, it has to be compatible with different type of operating systems. For example, it can include Windows operating system, Mac operating system, Linux operating system, Android for mobiles, iOS for mobile systems. So whatever application we are developing, now users will be using it on multiple operating systems. So we have to make sure that it operates very smoothly on different type of operating systems as well. That comes under operating system compatibility. Browser compatibility. Now there can be a multiple type of browsers like Chrome, Firefox, Safari, Edge, etc. And there can be different versions of browsers as well. So we should verify that our web application which we are using should be compatible across, or it should work correctly across different web browsers and their versions. So during testing we should test on multiple browsers and their versions as well. Device related compatibility. So we have to test on various devices including desktop system, laptop, tablets and smartphones to confirm that the software's performance and user interface across different screen sizes and resolutions. So let's take an example of some gaming application. So we have developed one gaming application which is for Android as well as iOS. But just testing on one Android device or one iOS device is not sufficient, because there are a number of versions in Android, there are different versions in iOS, there are different type of screen sizes available in the devices. So we should verify on different devices as well. We should verify on smartphones, we should verify on tablets, etc. That comes under device compatibility related testing. One more factor is network compatibility. So checking the software's behavior under the different network condition, such as different type of network bandwidth, latency, and network type. For example, we can check the behavior of application on the Wi-Fi network, let's say 4G network, how it behaves on 5G network, etc. So ideally it should behave constantly across different type of network as well. That we have to verify during network compatibility test. Software compatibility. We should ensure that the software interacts correctly with other software applications, including the different version of libraries, plugins, and third-party tools. So let's say we have developed one software application that should work correctly with other applications as well, because our system can have multiple applications installed in our system. So there should not be any problem with other applications. Along with the software, Hardware compatibility also important. We know that systems can have different type of hardwares like memory storage, RAM, etc. So we should verify that the software works correctly with different hardware configurations, such as processors are different, memory might be different, storage might be different across multiple devices, etc. So that comes under hardware compatibility. So these are the different type of compatibility we have to cover during compatibility testing depending on the requirement of application. There is one more type of compatibility that is known as forward compatibility and backward compatibility. What exactly is forward and backward compatibility? So they ensure that the software can function correctly with future and previous version of itself respectively. So whenever any web application is developed, it will start with first version, and in the future as the new features keep coming into the application, the version will keep upgrading. So first it will become 1, then it might become 1.1, 1.2, 2.3, 3.4 and so on. So versions will keep updating. So forward compatibility or upward compatibility refers to the ability of a system or the software to accept input intended for a later version of itself. This means current version of the software should handle the data, configurations and interface from a future versions correctly. It also ensures that the current system or software can work with data or interface from future versions. It helps in smooth transition for future updates without breaking the existing system. So there are two types. First one is forward compatibility and next is a backward compatibility. So let's take a simple example of what is forward compatibility. Now there let's take an example of document editing software. So let's say we have a current version of our document editing software and we are going to develop. So we are also working on development of new version, future version, that is let's say beta or alpha version of that software. So we have the current version, let's say this is the current version which we have, and we are also working on future version, that is beta version or alpha version, which is used for document editing with advanced formatting option. Let's say we have added some extra formatting options in the future version. Now for that, what is the forward compatibility testing we have to do? So what we can do is we can create the documents in the new version. That means you have to use the future version, that is beta or alpha version, to create the documents with basic as well as advanced formatting features. So in the future version, we have to do data formatting with basic operations which were present in current version as well, and along with that there can be extra formatting options which we have to perform on the future version. So basically in the future version, the basic operations should also work as well as advanced operations should also work. That comes under forward compatibility testing. For example, saving the document. So we can save the documents in a format that is intended to be supported by the current version. So current version, let's say we have intended to save a specific documents and that should work correctly in the future version as well. Opening in the current version. So let's say we have to open the documents which are created in the advanced version, but we have to check opening them in the current version as well. It should work correctly, right? Checking compatibility. So we have to verify that basic formatting like text, simple formatting, images, that functionality which is working correctly in the current version, it should appear correctly on the future version as well. Validating the other functionalities, like we have to ensure that the current version can still edit and save the document without losing the critical content, even if some advanced formatting options are not fully supported. So those are supported in future version, but it should work correctly with the current operations. We have to also check for any warnings and notifications. If there are features which are not supported in the current version, So we are adding support for the future version, but let's say they are not supported in the current version of the application. We have to ensure that appropriate warnings or notifications are provided to the user. So the main objective of forward compatibility testing is we have to ensure that the documents which are created in the new version can still be accessed and used in the current version, current stable version. It should be a smooth transition for users and minimizing the disruptions. So that is basically forward compatibility testing. Now what is backward compatibility testing? Let's take a simple example of messaging application. So let's see a popular messaging application releases a new version with additional features and enhanced security protocols. Let's see there is an application which is on version 1 and they have released a latest version, that is version 2. Now how we can do the backward compatibility? So backward compatibility means we have to ensure that the new version of the application does not break the functionality of the users who are using the previous versions of that application. So not necessary that users will always update the application. So there can be users who are using some older version of that application. So for such users, we have to verify that all the new versions of the application should not break the functionality of the users who have not updated the latest version. So how we can test it? So we should install the new version application on a device and then we can create a new version to create a message, send a message, including text, images and videos, etc. And then we can send those messages on older versions application. So we can check by sending those messages on older version of the application. For that we have to install older version of the messaging application on different devices. We can also verify that users with older version can still receive that messages, they can still read that messages and respond to the messages sent from the new version. So that is basically a backward compatibility. Whatever application we are upgrading, it will update for the new version correctly, but it should work correctly for older version as well. So that application should perform correctly for older versions as well. We have to ensure that all the messages appear correctly and there is no data is lost. For example, any images lost or any videos is lost. That should not happen. Also, those images, videos should not get corrupted for older versions. Those should be working fine on older versions. We have to also test the interaction. We have to also verify that users with older version of application can interact with users having the new versions without any issues. So let's say some users have updated to new version and some users are still on backward versions, older versions. The interaction between such users should not affected. It should work correctly between those two type of users. So this is basically a backward compatibility testing. So in forward compatibility testing, what we have checked? In forward compatibility testing, we have to make sure that whatever future version we are upgrading, so whatever the future version that is beta or might be a alpha version, and some features might be specifically for that specific versions. So we have to make sure that existing functionalities are working fine on future version as well. Whereas in backward compatibility testing, we are verifying that whatever new features are there, those should be compatible with backward versions as well. That is the difference between forward compatibility and backward compatibility. So this is all about compatibility testing. So we have seen what are the different type of compatibility testing. First one is operating system related compatibility, browser compatibility, device compatibility, network compatibility, software and hardware compatibility. And we have also seen what is forward compatibility and backward compatibility. Now let's move to the next type of non-functional testing, that is known as a recovery testing. So what exactly is recovery testing? Recovery, what do you mean by recovery? So Let's take a simple example. Whenever we are working on our system, sometimes we delete some of the files. But let's say sometimes we accidentally deleted some files and we want to recover those files. Where we go? We can go to recycle bin, and from the recycle bin we can restore those deleted files. So that is one type of a recovery mechanism. That is one example of deletion of file and recovering it from recycle bin. So similarly for our web application, let's say it is hosted on server, and due to some accident, let's say some data is deleted or let's say some data is lost. So there should be some proper mechanism to recover that data. So that is known as a recovery testing. So verification of data recovery in a situation of some accidental mistake or any data loss is known as recovery testing. It is a type of a non-functional testing that focuses on evaluating how well a system can recover from crashes, hardware failures, power supply failures, network outage, or any other catastrophic problems. Recovery testing ensures that the system can return to its normal state and resume the operation within acceptable time frame after a failure. So that is about the recovery testing. So recovery testing is mainly focuses on recovery of data during certain accidental conditions like network outage, power outage, application crashes, or any hardware failure, power supply failure, etc. It basically evaluates how well the system can recover the data and comes back to the normal state and resume the operation within acceptable time frame. So what are the some key aspects of recovery testing? Failure scenarios. So we have to simulate various type of failures such as hardware malfunction, software crash, network outage, and power failures. So while performing the recovery testing, we have to simulate various type of failure conditions such as hardware malfunction, software crashes, network outage, and power failures. And then we can verify the recovery process. We have to test the procedures in a place for a system recovery, including restarting the services, restoring database, and reloading the applications. And during that process, we have to ensure that no data is lost or corrupted during the recovery process. So while recovering the data, it should not become corrupt data. Also, there should not be any data loss. And we have to also verify how is the performance of the application after the recovery. We have to assess the system's performance after recovery to ensure that it returns to a normal operational levels. So these are some key aspects and key points about recovery testing. So what are the different steps involved in the recovery testing? So we have to identify the critical components. We should identify which components are crucial for the system operation and they need to be tested for recovery. And then we have to develop the failure scenarios. We have to create a realistic scenarios that could cause the system failures on our testing setups. Execution of failure scenarios. We should simulate the identified failures and observe the system's behavior. And then we can measure the recovery time. So once you start the recovery process, we should record the time taken for the system to recover from the failure. So whenever the failure happens, we simulate the failure, and after that we start with the recovery process. Then we should always verify and record the time taken for the system to recover from the failure. Verifying the data and the state. We have to check that data is intact and the system state is consistent after recovery. So after recovery also, system should not become unstable. The system should be intact and the system state should be consistent after recovery. And all these things which we do during the recovery testing, we should document the findings. We should document the result, including any issues, precautions, and any recommendations for improvement. All those things we should document in our document findings. We should record somewhere and we should document those because those documents becomes useful for the future. So these are the some points and steps which we should follow during recovery testing. So that is about the recovery testing. So recovery testing is again basically checking the recovery mechanism of our application during some accidental conditions. Now let's move to the next type of non-functional testing, that is upgradation and installation testing. So as the name suggests, upgradation testing, it involves verifying that a system can successfully upgrade from the older version to new version without any issues. So whenever user is going to upgrade the application, he should not face any issues during the upgradation activity. He should be successfully able to update the application from older version to new versions. We have to ensure that all the functionalities work correctly after the application upgrade. Data integrity should be maintained and no critical features are broken. That we have to verify after upgradation. So that is about the upgradation testing activity. So upgradation should be smooth and hassle free. Similarly, we can also check for installation testing. So whenever we are installing the application, the installation of application should be easy for the user. It should not take more time during the installation. It should be a less time consuming. That we can verify for installation related testing. And while installation, it should display some informative steps to user, and it should guide the user correctly so that user will not face any problem during the installation of that software. Along with the installation, we should also verify the uninstallation is also clean. So sometimes might happen that during uninstallation of the application, some files remain in our system. And if such files are remain in our system, if you try to install the software again, it will throw the problems. So we should always verify that whenever we are uninstalling, it should be a clean uninstallation. It should delete all the files related to that software. It should not keep any garbage files in the system. So that is about upgradation testing and installation testing, which is again a type of non-functional testing. So what are the steps for installation testing? We should prepare the environment. We should set up the test environment with the required hardware and software configuration for that software installation. We should also check the prerequisite. We should verify that all the prerequisites are met before starting the installation process. And then we can execute the installation. We should perform the installation steps as per the documented procedure. And once installation is completed, we should validate the installation. We should test the software to ensure all the components are correctly installed and they are functional. And as I said earlier, we should always test the uninstallation as well. Uninstall the software and we have to ensure that no residual files or settings are left behind. And we should always document the result. We should record the results of the installation and any issues occurred during the installation process. And we should inform the developer for such issues so that developer will fix those issues and installation will become smooth for the end users. So these are some important points about installation and uninstallation related testing. So with this type of testing, we have almost covered all the types of non-functional testing. So far we have seen performance testing, which covered load testing, stress testing, volume testing. We have also seen the security testing in our last lecture. We have also seen the compatibility testing. We have also seen upgrade and installation related testing. We have also have the overview of recovery testing, etc. So this is basically non-functional testing which we have completed. So in the coming session, we will see some more type of testings which are frequently used in our software testing process. Thank you for watching this video.